Got a cylinder here, and we're studying linear functions, and I'm going to give you linear equations and so forth. I'm going to give you an example of something that tends to be pretty linear. We're not going to take careful data on this. We're just going to do some pretend data. But okay, here's a cylinder. It's got a little hole in the end. I've got my finger over the hole, and I'm going to fill it with water. Ooh, looks like I'm missing the hole there. Okay. I usually use my thumb. Tends to work better on my finger. Okay, now I'm going to release the stream. There's a hole in the side here, that tube in there. Uh, and we're going to watch what happens to the stream. Okay, nothing surprising there. Um, Before I lose that water, I'm going to pour it back in. Oh, that's not what I wanted to have it. That was ignorant. Pour it into the bottle that doesn't have a hole in it. Losing a little bit, but it'll be fine. Okay, now we saw stream, and it was crossing the level of the container at one point or another. Okay, the stream's crossing the level of the container, and that point where the stream crossed the level of the container keeps moving backwards like this. Now, because of what physics tells us, physics predicts that that stream, that point should be moving at a constant speed. Okay, so that if we do an observation of the water, excuse me, I'm going to dry this off. Okay, if we want to do an observation of the distance r that the stream travels before hitting the level of the top of the container versus time, well, if we had a meter stick laying across here, we could maybe do that. Okay, we're not going to do it, but let's just say we did a similar experiment and we found that at time t equals 0, as soon as the stream started, r was 60 centimeters. Now, what do we mean by r? We mean the distance from a point just below the hole to the point where the stream crosses the top of the container. Okay? So this distance r starts at 60 centimeters, drops to 52, 40, 27, 21, 12, and 3 centimeter at 5-second intervals. So t equals 0, r is 60, t equals 5, r is 52, t equals 10, r is 40, meaning after 10 seconds, the stream is going 40 centimeters before it disappears down below the edge of the container. Okay, and so forth. Well, there's some good data. We can graph that data. Enough to construct the graph. There are lots of ways to do this, but I'm going to draw a rectangle. And I'm starting to write x. There's no x in here. I'm going to say time goes in this direction. And t equals 0 right here along this vertical line. And on this vertical line, t equals 32. And T is measured in seconds. Now, why do I choose 32 when this only went up to 30? Well, there are a lot of reasons I might do that, but the main reason I choose 32 is I can divide 32 in half, get 16, divide that in half, I get 8, divide that in half, I get 4. I can divide 32 by 2 a lot of times and get nice whole numbers. And you're going to see what the advantage of that is. Now, in this direction, R stands for range, the horizontal range of the water stream, but it doesn't really matter. That word doesn't matter. We're just going to use R, but the reason I'm using R is because of range. Okay. R can go up to 60 centimeters and it goes down to almost 0. Well, we're going to let R equals 0 along this line, which corresponds to the t-axis. And we're going to let R equal 64 up here. Why 64? Because you can divide 64 by 2 successively a lot of times. Okay, divide 64 by 2, you get 32. And of course, we know we can divide 32 by 2 several times. I'm going to create a grid on this graph. Okay, halfway between t equals 0 and t equals 32 should be right about here. If I sketch a vertical line through this point, then that ought to correspond to t equals 16. Now, you don't have to know how to do this, but this is just the way I'm setting it up, the way we did it in class. You're not going to be tested over this in the intermediate algebra class, at least. But there we get t equals 16. Then halfway between t equals 0 and 16 is right about here. So we sketch a vertical line. And halfway between 0 and 16 is 8. Now, halfway between 16 and 32 would be about here. And halfway between 16 and 32 is 24. Easy to calculate. 16 and 32 is 48. Divide that by 2, you get 24. If you add two numbers and divide by 2, you get the number halfway in between them, the average number, or average of the two numbers. The mean average, if you want to be precise, but we'll just say average. Okay, R is 64 here. It's 0 down here. So if we go to the halfway point between top and bottom, that was a little high there, but we get R equals 32. So I've already got something a little bit inaccurate. This is a hand-drawn graph. Hand-drawn graphs are going to tend to be, they're inevitably going to be somewhat inaccurate. We try to make them as accurate as possible. So that point should have probably been about there, but we're going to live with it where it is. Halfway between here and here, halfway between the R equals 32 and the R equals 0 line, we have the R equals 16 line. Halfway between the R equals 32 and the R equals 64 line is R equals 48. Now, my grid here isn't very good. From R equals 0 to R equals 16 is this big here. So 16 units on the R direction ought to be this big. But up here and up here and up here, it's much smaller because I made this thing too high. Then I made this thing a little higher than I should have. So it's not going to be, we're not going to get a massively accurate graph, but just demonstrating, and you'll see a more accurate graph that we're actually going to use. Now we plot the points. T equals 0, R equals 60. Well, T equals 0 is here. R equals 64 is up here. 60 is going to be maybe about here. T equals 5. R equals 52. Well, where's T equals 5? Here's 0 and here's 8. Halfway would be 4. T equals 5 would probably be, oh, maybe along this line. Maybe I've got a little too far to the right. And 52, R equals 52 is a little above R equals 48. It's actually as far above 48 as 60 was below 64. So we can pretty well see where to mark this point. Then we keep doing this. T equals 10, R equals 40. 10 is, if 8's here and 16's here, then 10 is about here. And R equals 40. Turns out to be halfway between 32 and 48, so we can locate that pretty accurately. So we've got this point. 15, 27. 15 is just a little less than 16. 27 is between 16 and 32, about a third of the, 2/3 of the way from 16 to 32. So without drawing a bunch of lines, I'll put a point about here. I think that's fairly accurate. T equals 20 is halfway between 16 and 24. And R equals 21 is between 16 and 32, but about 3 times closer, twice as close to 16 as it is to 32. So by point 2021 ought to be about there. Now, not notably accurate, but just demonstrating the process. 25, 12, well, 25 is a little to the right of 24. 12 is 3/4 of 16, so it's about 3/4 of the way up there. And then 33, 30 is a little to the left of 32, and 3 is pretty low. So I've got these points. I can take a piece of string, and I thought I had a piece of string handy here, but I don't know what's happened to it. And then I'll have a little string. And I can figure out where the line is that's on the average closest to these x's than any other line. Okay. Now I can't do a line. You know, people tend to want to do a line for the first point and the last point. That's not good because most of the points are on or above that line. There are no points below that line. So that line doesn't fit the data as well as a line that maybe is a little bit more up here, a little bit more down here. Okay. So we, in any case, figure out where that line ought to be and we sketch it. And maybe it'll be something like this. Okay. That line's going to have a slope and it has an equation. Your equation, standard equation for a straight line is y equals mx plus b. There's your slope-intercept form. M is the slope, b is the y-intercept. In this case, we're not using y and x, we're using r and t. So the equation is going to be r equals mt plus b. Makes no difference what letters you use instead of y and x. But the number used for x ought to be in the horizontal direction. The number used for y ought to be measured in the vertical direction. Now, let's see the graph that we actually made. And there's a bunch of stuff written on this graph that you don't need to think about right now. Just look at the x's that mark the points, and you see something pretty similar to what you saw before. It's a little more accurate because my scale is a little more accurate here. I was a little better at hitting halfway. I still have the same labels, t equals 0 to 32, with 16 in the middle, and then 8 and 24 between those points. And t equal, r equals 64 up here, r equals 0 down here. I got the r equals 0 written over here because it would have been in the way over here. So there's my grid. And let's see, should have labeled r up here. There's r in centimeters, measured along this axis, t in seconds, measured along that axis. Here is the line that I drew for best fit. It does coincidentally go through this point, but that's just a happy accident. It missed the point, but not by very much, and you pretty much can't see how much it did miss. Okay, now we want to write the, it's not y, it's r. R equals m times y, m times t plus b equation. And I'm going to write that with blue chalk, and I don't know what's happened to my blue chalk. When in doubt, look on the floor. There we go. Okay, I should have had R up here. And it looks like my blue chalk got wet. It also looks like it's broken off, probably because it got wet. It was on the floor and we were using water. Okay, well, I've reversed the chalk and now I've got good chalk to write with. So still, okay, let me write a good R, but that's supposed to be R equals, and it's not, yeah, R equals MT plus B. Hope I didn't make that mistake anywhere else. Okay, R equals MT plus B. That's the equation we're trying to get. Now, what's the meaning of M? M is the slope. How do we get the slope of this line? Okay, we want the equation of the line. Well, we want to use points pretty far apart. So if we make little errors in estimating the points, they aren't going to make as much difference because we're multiplying or dividing by bigger numbers. So I estimated that, and I called it X. I estimated that R is 57 where this point intersects the R axis, or where this line intersects the R axis. So this point here would be 0.57. Now, the point here is 0.60, corresponding to the first row, but the line hits a little bit lower than that point. So I estimated R equals 57. A better estimate from this picture would be R equals 58, but that's not going to turn out not to make too much difference. So we have the point 0.57. Now there's an arrow pointing at it, but there's a lot of stuff up there. It might be a little hard to see, but we can see that this point here, where the red line crosses the R axis, is approximately 0.57, maybe 0.58. I'm going to use the intercept down here too. Where does the line intercept the t-axis? Well, this point here was 33. But the line pretty much almost goes through that point, and then it hits the t-axis about here, which is, well, here's your t equals 32 line. Here's your t equals 30 line. It looks like 31. So it looks like this point is 31, 0. Okay. Now we want to find the slope. Now what's slope? Well, there's a formula, y2 minus y1 over x2 minus x1. I don't like that formula as the first way of calculating the slope. I like rise divided by run, rise over run. Okay. So we're going to find the rise and the run from this point to this point. We start at this point and we draw a path parallel to the coordinate axes. It's a broken path. It's going to have two segments. It's going to go from here to here, then from here to here. This part is parallel to the R axis. This part is parallel to the T axis. And of course, they're perpendicular. And there are arrows on them that indicate the direction you have to go if you want to go from this point to this point. Wouldn't make any sense to have the arrow on this end, because then you come down here and you'd run into that arrow that's pointing this way. You wouldn't be able to go any further. Arrow goes this way, then this way. Shows you the direction of the path from this point to this point. Okay. Of course, there's another path which is right along the red line, but that's the point. That's the line we're trying to find the slope of. Why do we do these arrows? Because this arrow is the rise and this arrow represents the run. Rise is up or down. Now, rise is up if it's positive. a negative rise would be down. So we have, in this case, a negative rise, and you can see that we go from R equals 57 to R equals 0, so we're going down 57. Okay, so the rise would be negative 57. Now we want a way to calculate that. When you calculate how the arrow from one point to another, you subtract where it starts from where it ends. So you're going to subtract 57 from 0. Okay. And that's what we do. The rise is what we get when we subtract 57 from 0. 0 minus 57, which is, of course, negative 57. And that's consistent with what we've already seen, that we go 57 units down, get from here to here. What's the run? Well, it's obvious that it's 31. We're going from 0 to 31, but let's write the calculation. Where we end up minus where we start. 31 minus 0, that's 31. So there's the rise and there's the run, and now we can write down the slope. Now, this graph down here, it's just another, I used it as another explanation of how we do this, but I already did that on a different board. So you can just kind of ignore this. Okay, so from the triangle we drew, we got the rise equals negative 57, the run equals 31. Now think again, why did we do that? We did that because we're trying to find R equals MT plus B equation. R and T are going to be our variables. M is going to be our slope, and B is going to be our y-intercept. In this case, the vertical intercept, or the r-intercept, because this graph doesn't have y, it has r. Okay, we got the rise and the run, so we can easily write down the slope. So slope equals rise divided by run, which is negative 57 over 31. So y equals mx plus b, there's our standard form of the equation, but we're not doing y versus x, we're doing r versus t. We have r equals mt plus b. This becomes r equals negative 57 thirds t plus b, because m is negative 57 thirds, or 57 over 31, sorry, negative 57 over 31 plus b. M is negative 57 over 31, that's our rise divided by our run. So we have this equation. R and T are still variables, but we got to figure out B so that we can have an equation. What's B? Well, B is the vertical intercept, which in this case is 57. So it's very easy to see that what the equation is going to be. The equation is then going to be R equals negative 57 over 31T plus 57. Now there's a formula for calculating the slope. And some people are visually impaired, and naturally you would want to use the formula. And even if you are visually impaired, the formula helps keep you straight. But the picture also helps keep you straight. So if you have the picture, you're going to have two ways of understanding slope, and that's a real advantage. But it's no big disadvantage to be able to just calculate it from the formula. So the formula for the slope is m equals y2 minus y1 over x2 minus x1, where x1 and x1, y1 and x2, y2 are the points. So the slope of x1, y1 to the point x2, y2 is m equals y2 minus y1 over x2 minus x1. Okay, what are the 2 points? Well, the 2 points that we estimated on our graph are 0, 57 and 31, 0. So x1 is 0, and actually it's not, this would be from x1, y1 to x2, y2. In this case, it would be from r1, t1 to r2, t2. So let's make that translation. R1, t1 to r2, t2. Slope is rise over run. Instead of y2 minus y1, okay, it's going to be t2 minus t1. And that's wrong. It's going to be r2 minus r1. Since r is your vertical variable. So it's r2 minus r1. In standard form, but on a graph of y versus x, y in the vertical, x in the horizontal, it's y2 minus y1 over x2 minus x1. Y is the vertical, so that's where you measure the rise. X is the horizontal, so that's where you measure the run. If you're graphing R versus T, then R takes the place. I've written this wrong again, and I said it wrong again. So let's say it right. R takes the place of Y, and T takes the place of X. So from the point T1, R1 to T2, R2, those are the proper coordinates for the example we're using. For T1, R1 to T2, R2, the slope, which we'll call M, is vertical minus vertical, R2 minus R1 over T2 minus T1. Well, our 2 points are 0, 57. That's our R1, T1, and R2, T2 is 31, 0. If you do R2 minus R1, R2 is 0, R1 is 57. So you get 0 minus 57 divided by T2 minus T1, okay? Now, T1 is 0, T2 is 31, so it's going to be 31 minus 0, and that gives us negative 57 over 31, just as we got it from the picture. So there's our formula, there's our picture. The rest is just as we did it. Once we know the slope, we know that R equals MT plus B becomes R equals negative 57 over 31 times T plus B. B is the vertical intercept, which is 57. The vertical intercept occurs at the point 0, 57. Say the vertical intercept is 57. That's our value of B. We put that into the equation R equals negative 57 over 31T plus B, and we get R equals negative 57 over 31T plus 57. Okay, now, this is a little confusing because we're using R and T instead of Y and X. And I admit that it would have been better to start with an example just using X and Y. But I thought it would be good to see this in context. So if you don't totally understand this right now, come back to it just a little bit later. And understand that we're replacing Y with R, replacing X with T, simply because those letters make more sense in terms of what we were observing. And let's do an example where we find the equation of a line between 2 points. Okay, let's say we have the 0.37 and the 0.1012. The way I recommend doing this is first, if if you're able to sketch a graph, represent the 0.37 and 1012 is 2 points reasonably located on a graph. Then if we draw a horizontal line from 3,7 until we're right under the point 1012, that line is going to run from, 3,7, x equals 3, 1012, x equals 12. We're going to run from x equals 3 to x equals 12. Run is in the horizontal direction. X is usually graphed in the horizontal direction, traditionally graphed in the horizontal direction. And you see that our arrow will have we call it a displacement. The run is going to be, again, from x equals 3 to x equals 12. Well, how far is that? It's 9 units. But we do 12 minus 3 equals 9. And it's positive 9 because our run is in the positive x direction. It's to the right. If we always go from the leftmost to the rightmost point, then our run will always be positive. And I recommend that we kind of do that. If you end up with a negative run, that's okay as long as you're careful about the signs. But I recommend a positive run. And then your rise. Now, in this case, the rise is positive because we're going from 3,7 to 1012. The y coordinates are 7 and 12. We go from y equals 7 to y equals 12. And that's a distance of 5. But of course, if we subtract 7 from 12, we get 5 automatically. In each case, we've subtracted where we are from where we're going. To get from x equals 3 to x equals 12, the run is 12 minus 3. Where we're going minus where we are. We're going to 12. We're starting at 3. 12 minus 3 is 9. The rise, it's where we're going, which is to 12, from where we start, which is at 7. 12 minus 7 is 5. There's the rise. So with this simple triangle, we've depicted the rise and the run between the two given points. Now we can always, of course, use the equation, the formula. 0.37 be the point x1, y1. So I'll just kind of write that in here, x1, y1. And the point 1012 would be the point x2, y2. And the slope is y2 minus y1 over x2 minus x1. So I'll write that in over here. I can't read the word, it says compare. M equals y2 minus y1 over x2 minus x1. If you're constrained to work by symbols, you can do this easily. Y2, well, again, the point x2, y2 is the point 10, 12. So y2 is 12. So we replace y2 by 12. And y1, well, the 0.37 is 0.1. Y1 is 7. So we get 12 minus 7. That's your y2 minus y1. And x2 minus x1, well, 0.2 is 10, 12. X2 is 10. 0.1 is 3, 7. X1 is 3. So you're going to do You know, the thing I've written up here is kind of wrong because when I drew my vertical line through the second point, I said X was 12. But the second point is 10, 12, X is 10. I'm going to make a change so that I make everything I've done correct. Instead of 10, 12, the first or the second point should be 12, 12. Okay, I apologize. That's just a plain old error. When I labeled the X equals 12 vertical line, I was just caught the number 12 out of the corner of my eye, and I did that. So once more, if the second point is 12, 12, then everything I said earlier is correct. If the second point was 10, 12, it didn't work. Okay, so just briefly again, our run now would be from X equals 3 to X equals 12, as I said earlier, but that now corresponds to the point 12, 12. Okay, the rise is as it was before. Okay, so we compare. M is y2 minus y1 over x2 minus x1. Y2 is 12, y1 is 7. Well, that's correct. And now we do x2 minus x1. x2 is now 12 because the second point I've changed 12, 12. x2 is 12. x1 is the x coordinate of the point 3, 7. So x1 equals 3. And we have 12 minus 3. This comes out 5 over 9. Same as it did with the triangle. So now we can write our equation either way, y equals 5/9 x plus b. How do we find b? X and y are variables. The parameters are m and b. The parameters are things that stay the same no matter what the variables are. Okay? M stays the same, b stays the same. Okay, well, in order to find b, if we know the values of y and x, we can find b. Well, we have 2 points. We have 2 xy points from which we can easily find b. So we choose a point, either 3, 7 or 12, 12. We have the instruction written down here. We find b by substituting the x and y coordinates of one of our known points. We've chosen point 1, so we're going to let x equal 3, y equal 7. If we do that using the point 3, 7, we substitute x equals 3, y equals 7 into our equation, y equals 5/9 x plus b, and we get 7 equals 5/9 times 3 plus b. Again, y is 7, so our left-hand side is 7. We have 5/9 x, but x is 3, so we get 5/9 of 3 plus b. To solve this equation, we multiply first, we multiply both sides by 9 because most of us are not all that comfortable working with fractions. It's actually easier, even if you are comfortable, to clear out your fractions. Let's see how that works. If we multiply the left-hand side by 9, we get 9 times 7, which is just 63. If we multiply the right-hand side by 9, well, we've got to multiply the 5/9 of 3 by 9, and we got to multiply b by 9. So it's 9 times the quantity, 5/9 of 3 plus b, which becomes 9 times 15/9 plus 9b. Multiplying through by 9. And then 9 times 15/9 is just 15. Our left-hand side is still 63. So we get 63 equals 15 plus 9b. Then we write the equation minus 15 equals minus 15. Below the equation, 63 equals 15 plus 9b. And we add the two equations, and we get 48 equals 9b. Of course, officially, we could write 9b, 15 plus 9b minus 15, but the 15 minus 15 gives us 0. So we've just got 9b. Now, if you're looking at this, that b looked a whole lot like a 6, but I've just made it look more like a b. Okay, so we get 48 equals 9b, and then we divide both sides by 9. 9b over 9 equals 48 over 9. 9b over 9 is just b, so we get b equals 48 over 9. Okay, well, we started this little phase knowing that y equals 5/9 x plus b. Now we know b, and we can write the equation y equals 5/9 x plus 48 over 9. And there's our equation. Now there's a formula you can use for the equation. It's y minus y1 equals m times x minus x1. Okay. And of course, m is your slope. Now I recommend calculating m separately. So if you first calculate m using the rise and the run and plug it into the equation, then you just need to substitute for y1 and x1, and everything works out just the way it did when we went through the process just now. There's a formula, y minus y1 equals m times x minus x1, which is just, if you divide both sides by x minus x1, you get m equals y minus y1 over x minus x1, and that is a slope. The equation can be complicated sometimes by replacing m with y2 minus y1 over x2 minus x1. So now the equation is y minus y1 equals y2 minus y1 over x2 minus x1 multiplied by x minus x1. Now that equation can look a bit complicated. For the equation we wrote before, y minus y1 equals m times x minus x1 is less complicated, but it causes you to have to go out and calculate m. In the equation I just wrote, where m has been replaced by y2 minus y1 over x2 minus x1, you don't have to think about anything. You just plug in x1, y1, x2, and y2, and you have an equation, which you usually then solve for y. Now, I prefer that you think about things, that you, if you can see or imagine a picture, to do so you can see this equation in its geometric glory. However, either way is okay. I advocate the picture if that's feasible for you, because it's a check against the equation. If you use the picture, then use the equation and get different results, you're going to have to reconcile it. And that's going to lead you to a better understanding and better memory. If you remember the picture and the equation, and they are consistent, then you're in very good shape. If you know only one of them, well, if you know it well, you're still going to get the right stuff. So I advocate, whenever possible, to have a picture as well as formula. So that's kind of it for right now. There's an assignment, and I might have to modify that assignment because we got hung up on a couple of things. One thing is that Zoom just kind of crashed on us. Okay, so I'm doing this after class. There we have it. So good luck on the homework, and let me know if you have questions.